So that's one. We have two here, one around the other. So it's even more challenging. It's not only crazy make one. How do you do two? Kissing each other to the point that they merge. So there are two ways. One is the two stars are born, two giants, two hypergiants born together. We don't see them. But they're born together, and first one, then the other explodes to leave the black hole. This companion, the second one, in some way managed to survive next to this monster explosion. Not easy. But one goes, the other goes, and you get the binary black hole, and the binary black hole stays there, because at some point they orbit together, and eventually they merge. The other one is that, these are ideas, the other one is that they have nothing to do one with the other. One star goes, more regular, a big mass, a big star, as the one that we sometimes tend to see, maybe not as big. The other goes, and then they meet each other, and they start dancing one together with the other. Now, in order to get this pairing, you need a little bit of help from the others. It's like, when you want to, all these stories that people, you facilitate the encounter. And the encounter is facilitated by the fact that there are other stars around. You need to dissipate momentum. There are some law of physics that you need to use to bound this to crazy stuff, and which means that they are young, they get connected when the rest is still around. Because these systems of massive, all these clusters of young stars end up in a few million years as well. So it's something that magically happened at the beginning. Either they are born together or they meet together very soon. And eventually they explode. We don't know. How can we know? And this is my last couple of slides are just questions, things that we don't know. Because it's true that when we learn something, there is always more than our wonder increases, and new questions come out. This is the fascinating game of science. How do we know if this is one or the other? Maybe it's a third one, of course, and people may come with a fourth one, and there are very creative colleagues. So one of the things is this one. If the stars are born together, they always tend to spin. And spinning has a preferential axis. And the other has another axis, and they go around one to the other. And we know that when systems come from the same original cloud, all these rotation axes are the same. There is like a coherence. The Earth spins, the Sun rotates, Jupiter rotates, there is the ecliptic. Actually, everything is sort of around the same axis, normally. There are exceptions, but typically all these bodies, even our little solar systems, we tend to spin around the same direction. That's a hint that something coherent and global was going on at the beginning. A super rotation, and then this instinct to rotate, we call it angular momentum, got distributed. I take a little bit, you take a little bit, but we tend to preserve that fundamental axis. This is, if you instead capture, then I go this way, you tilt around the other axis, and maybe the orbit is even crazier, right? And at this point, this angular momentum get completely disconnected, and the directions start to talk one with the other, and you get this strange phenomenon we call precession. It's when you have a spinning wheel, when you have, how you say, una trottola? The one, if it is perfectly vertical, it spins. But if you tilt a little bit, starts to do strange rotations. Why, right? But there is a coupling between the fast spinning and the vertical axis. The net effect is that slowly things move around. And this is what may happen. So if they are born together, you should not see precession. But if they are captured, you may see precession. And this is a measure that they may do. They may be able to see this, the signal of a precessing or not precessing pair of black holes. What is left? Well, what is left is this monster black hole, which has a lower mass, the total -3. Cannot even think about that. Make 3 sun and evaporate them. Talk to the, Star Wars. You're kidding me, right? That's ridiculous. This is 3 solar masses. And, but what we know is that there is no more signal. And the fact that there is no more signal means that the space-time after is really not perturbed by strange motions, which probably means that at least to some extent what is left is a spherical black hole. It's not elliptical, it's not a partial merging. It's a nice order has been resumed and space-time is not warping anymore because we are not seeing any leftover after that. It's really back in the noise. So to some extent has been the emerging a spherical structure. And are we going to see more? Yes, that's already, we know that we are going to see more and more, and not only binary black holes, but as we improve the sensitivity, we will see more of the other categories, because now we are grazing the big beast, but we will see the mergers of neutron stars. We will see, actually, you know that there's won a Nobel Prize that was assigned for a couple of scientists that discovered a binary neutron star. So before the merging, there is one system that has at least one, and more than one now, has been discovered, and they are spinning, and what happens is they are spinning faster and faster and faster and faster. We are measuring this. One day they will merge and create their own smaller gravitational wave. So we are seeing, we had already, the Nobel Prize was already assigned for something that smells like the anticipation of a gravitational wave from a binary neutron star. And then all the mixes, and who knows what we're going to get. Other questions, where are they? We know how distant are they. We know how distant. There are tricks to measure the distance with good accuracy, can be better. To measure where are they, we need the Italian, French antenna at least. We need the 3, right? Because with 3, you can basically triangulate in which direction is in the sky. As soon as we know where are they, then we do the last step, the one that we really care about. Can we see them with the telescope? The flash, something. Maybe in the X-rays. We hope so. We hope so. There is, I mean, can you imagine these 3 masses that go, they must touch. Remember that there is this, all this material around that has just been blown. And maybe we can see the impact of the black hole on the wind, on what has been left over. So we really hope to see, if they tell us, look there, we go with the telescope, look around, nail it down, measure, we may get the electromagnetic signature. That will be a nice complementary measure to understand what's going on. And the last slide is this one. I mean, we go back to Einstein. There are many quotes on the internet. Who knows if he said all what they say that he said. I'm always skeptic. You should go to the entire. But this is a good one. The comprehensibility of the world seems to me a wonder or eternal secret. Here lies the sense of wonder, which increases even more with the development of knowledge. It's very true that the more we know, the more we stay in wonder, the more we ask, and the more we stay, I think, as we were saying before, it's really in shock, because it's a cosmos, it's an order, and there will not be no reason for finding that everything works between what we see, this math, which is probably something that we have in our mind, and the universe in some way knows what we can think, and reacts in the same way. It's a fascinating question about that points clearly to a more deeper and fundamental order. It's a cosmos. It means order. It's not chaos. It's a cosmos. There is an order there that is hinting to us, look at me. And this is what we are doing.